Hello friends, welcome back to my channel. So till now we have seen the supply system in which we have covered the deck tank, and then we have seen the fuel gas supply system, that is the FGSS skid. Then after that we have studied about the fuel wall train, and in the last video we have covered this double wall piping system. So till now the LPG is supplied through supply system, and through fuel wall train it is about to enter the main engine. So in this video we will see what all components are there on the main engine that are needed for its operation on dual fuel mode. So basically we will see what all modifications or changes are done on the main engine for its operation on propane, or you can say LPG. So let's begin with the video. So the double wall piping enters from the deck into the engine room, and it is connected to the main engine for the supply of secondary fuel, that is the propane or the LPG. So just before they are connected to the main engine, two isolation valves are provided, one at the inlet pipe and other at the outlet pipe. And these valves are basically manually operated valves, and they basically isolates the main engine from the LPG or the propane supply system. So these valves are also provided with limit switches. So these limit switches basically acts as safety, that in case the valves are shut, then in that case we won't be able to change the main engine from primary fuel to secondary fuel. So these are basically interlocks for the operation. These sensors are basically for the interlock of secondary fuel mode operation of the main engine. And these valves are used when we need to carry out some kind of maintenance on the main engine. So when maintenance need to be done, then these valves are shut to isolate the main engine from the supply say or secondary fuel supply system, and the maintenance can be carried out safely. So the double wall piping coming from the deck into the engine room is connected to the first unit of the main engine, as you can see over here. In this diagram also you can see these are the piping which is coming from the deck, and it is getting connected to the first unit of the main engine. And all other units are connected to each other with the help of these chain piping. So as you can see over here, these are called the chain pipings, and with the help of these piping inlet and outlet, the other units are connected. So basically one is connected to 2, and from 2 to 3, and 3 to 4, and so on. And the last unit of this main engine, this section over here, as you can see, if this is the last unit, then this section will have solenoid valves to connect the inlet to the outlet. So basically the full supply system is connected to each other with the help of chain piping, and all these chain pipings are basically double wall pipings. So we have seen how the double wall pipings are connected to the main engine. This over here, as you can see, this is the adapter block for the secondary fuel. So in this only the double wall pipings are getting connected. The upper two holes over here which you are seeing are for the inlet pipings, and the below holes are for the outlet piping. So now we will see what all extra LGIP components are mounted onto the cylinder head of this ME engine for its operation on dual fuel mode. So basically these LGIP engines, they are working fine with the primary fuel. Like that when the secondary fuel operation is not there, then they are working like normal ME engines. But when they are at high seas, then at that time we can change over the main engine from primary fuel to secondary fuel. Then at that time they need different kind of arrangement for injection of LPG into the combustion chamber. So we will see that how this LPG is injected into the combustion chamber of these LGIP engines. So for proper understanding of dual fuel components which are incorporated into the LGIP engine, let's first see what all components are there in the normal ME engine for the fuel oil injection into the combustion chamber. So as you can see over here, this is the schematic diagram for fuel oil injection system for the ME engines or normal ME engines. And this over here is the fuel booster unit. So this fuel booster unit basically pressurizes the fuel oil to injection pressure. And for proper atomization of fuel oil into the combustion chamber, fuel injectors are mounted onto the cylinder head. So these fuel injectors basically atomizes the fuel oil for proper ignition into the combustion chamber. Now for actuation of these fuel boosters, we use system oil. So this system oil is pressurized to at around 200 to 300 bars by the attached pumps. So this pressurized oil basically actuates this booster for pressurization of the fuel oil. Now, two main things are also needed for the proper combustion into the combustion chamber. One is the quantity of the fuel, which is needed as per the load requirement, and the timing. So basically, for two-stroke engine, fuel is not injected all the time. A particular timing is there. So for this timing as well as the quantity of fuel that need to be injected is controlled by the control system, which is incorporated onto the main engine control system. So this is so all these things are there in the ME engine for its proper functioning. So if we compare the fuel oil components of normal ME engine with the secondary fuel components of the LGIP engine, then we can see that there is a FVIV, or you can say the liquid gas injection valve. So this valve is basically the combination of fuel booster unit as well as the fuel injector. So this unit over here, as you can see, this is the FVIV valve, which has the function of both the fuel booster as well as the injector. So this part of this booster is used for pressurization of the LPG, and the below part is used for the injection of the LPG into the combustion chamber. So we can say that this FVIV valve or the liquid gas injection valve basically carries out function of both the components of booster as well as the injector. So for the pressurization of LPG to injection pressure, some kind of actuation or actuating medium is needed. So over here also the system hydraulic oil is used, which is pressurized to at around 200 to 300 bars by the attached pumps. So that pressurized oil is applied onto this plunger, and that basically pressurizes the LPG over here, and this pressurized LPG is injected into the combustion chamber with the help of this FVIV, or you can say the liquid gas injection valve. So the hydraulic oil which is used for the actuation of this liquid gas injection valve, that is the FVIV, is always maintained at a pressure of 200 to 300 bar pressure. So if this pressurized oil is continuously supplied to these FVIV valves, then it won't function properly. So this hydraulic oil need to be timed and controlled. So for that purpose we have FVIV actuator control valve. So this valve over here, this is basically a solenoid valve. So this valve is used for the control of this hydraulic oil in the booster, or you can say the FVIV valve. So this this FVIV actuator control valve is also called the LV. So I would like to tell you in detail about this LV in the later section of the series. So this LV basically controls the actuation of this FVIV. But as we have seen in the normal ME engines, the pressurized fuel oil basically uh, operates the fuel injector, and with the fuel pressure itself, the injector operates. But over here, this is not the case. We need a separate system for injection of LPG into the cylinder chamber, or you can say the combustion chamber. So for that purpose, we have this LG. LG also we will cover in the later part of the series. So this LG is also a solenoid valve. This valve operates and this injects the pressurized LPG, or basically helps in atomization of the pressurized LPG with the help of the FVIV valve into the combustion chamber. So this valve basically controls the timing as well as the quantity of LPG which need to be injected into the combustion chamber. So we have this LV valve for the actuation of this FVIV or liquid gas injection valve, and then we have this LG, which is basically controlling the hydraulic oil for the injection of LPG into the combustion chamber. So these two valves are there and they are basically controlled by the engine control system for the proper functioning of the fuel oil injection system. Now the next thing which we will see is this sealing oil. So this sealing oil is basically maintained at 80 bar pressure at all the time in the FVIV valve, or you can say the liquid gas injection valve. So at all the time this sealing oil is maintained at 80 bar pressure in this FVIV valve. This basically separates the hydraulic oil which is at 200 to 300 bar pressure and the LPG in the FVIV. So this sealing oil is basically acting like an O-ring in the FVIV. So to summarize, the main engine system oil is pressurized to 200 to 300 bars. Then this pressurized oil is used for the actuation of this FIVA valve with the help of this LV. And for the injection purpose, this same oil at 200 to 300 bars is used for the injection of LPG into the combustion chamber with the help of this LG valve. And this 200 to 300 bar pressure is reduced to 80 bar, and then this reduced pressure is maintained in the FIVA valve as a sealing oil. So this sealing oil is always maintained at 80 bar. So this is a kind of safety. You will get a better idea about this fuel injection system when we will cover this FVIV. So when we will see the operation or the working of this FVIV valve, then at that time you will better understand what I am talking about. So now we have the overall idea of how the LPG is injected into the combustion chamber. Now let's see what all components are mounted onto the cylinder head. So if you see over here, this part, this is the control block. So all the components which are needed to control the injection of LPG into the combustion chamber, they are mounted onto this control block. This down part, I have already told you that this is the adapter block over the into which the chain pipings are connected for the supply of LPG. So the LPG from the adapter block enters the control block, and over here the timings are controlled for its injection into the combustion chamber. So for that purpose, we have already covered that what all things are needed for the control of timing as well as for the quantity of fuel oil injection. So for that purpose, we have this LV valve. So this LV valve is this one, which is basically actuating the FIVA valve for the pressurization of LPG. And the second thing is the LG, this LG. So this over here, as you can see, this is the LG valve, which is basically controlling the timing for the injection as well as the quantity of LPG that need to be injected. So these two all valves are there. They are the most important things. Now the next component which is mounted on this control block is this HPS oil accumulator. So this oil accumulator is mounted on to the hydraulic line of LV. So this LV line, which is used for the actuation of FIVA valve, on this line this HPS accumulator is mounted. So similar to this HPS oil accumulator, there is accumulator for this control oil also. So that accumulator is actually not shown on this diagram, but there is accumulator for this control oil pipe. So this basically reduces the pressure fluctuation in the control oil system. Now the next component is the pressure transducers. So these pressure transducers are mounted onto this control block that provides the LPG pressure to the control system and to the safety system of this main engine. So now we have discussed mostly all the components which are mounted onto this control block. So control block basically provides everything that is needed for the actuation of FIVA valve for the injection of LPG into the combustion chamber. Now to connect this control block to this FIVA valve, there are three hydraulic lines. One hydraulic line is this one. So this is basically the hydraulic line in which the actuating oil is supplied. So basically the oil supplied by this LV is passing through this hydraulic pipe. Then we have the control oil hydraulic pipe. So this control oil hydraulic pipe is this one. Small yellow line is there, na? That is the control oil line. This line is basically used for the injection of LPG into the combustion chamber. And there is one more line for the sealing oil. So the sealing oil is there. So this control block basically provides the sealing oil to this FIVA valve through this line, sealing oil high pressure line. And you must be thinking that where is the pipe for the LPG which is going for the injection. So basically the LPG is going through the internal holes onto this cylinder block. Now we will go on to this adapter block. So this adapter block is provided, as I have already explained in my previous slides, that the inlet pipe coming from the deck into the engine room is getting connected to this adapter block of the first unit of the main engine, and from the first unit to the second unit, and from the second to the third, and so on, the supply is connected by the chain pipings. So as you can see, this supply system is basically connected with the help of these adapter blocks. Now the other component which are there on mounted onto this adapter block is the accumulator for the LPG line. So the fuel oil accumulator is mounted onto this adapter block. Now the next thing which is mounted onto this adapter block are the inlet and the outlet solenoid valves. So this solenoid valves basically help during the pressure testing of the intactness of the components which are mounted onto this cylinder head. So these inlet and outlet valve basically at the beginning or at the starting of engine onto the secondary fuel mode, then at that time these two valves help during the pressure test and as well as for the supply of LPG to the main engine. So now we come to the most important thing which is incorporated into this adapter block. So this over here, as you can see, this is the cover. So this cover basically is for the gas detection holes. So the if you open this cover, you will see something like this inside this cover. So these are the gas detection holes which are incorporated onto this adapter block. So details about these holes and working of this gas detection system, that we will cover in the other video. Over here, just remember that there is something called gas detection block onto this adapter block that basically helps in operation of the main engine on dual fuel mode by detecting if any kind of leakage is there. So with the help of these holes, we can know exactly which components o-rings are damaged and which components are leaking. So with this block we can very easily find out where is the problem. So remember that, and how the problem how we can basically carry out the troubleshooting or the fault finding with the help of these blocks, that we will cover in some other video. So till now, what all things we have covered for the adapter block. So all these components are there in all the units. Now we will see the components which are there only on last unit of the main engine. So the provision for the sealing oil is basically mounted onto the last unit of the main engine, and there will be a separate bypass valve provided that connects the inlet and the outlet pipe. So basically on the last unit there will be one bypass valve that will connect this inlet and the outlet double wall piping or the chain piping. Okay. Second thing is the components which are needed for the supply of sealing oil onto this cylinder head FVIB walls. Then for that there will be a reducer. So the 200 to 300 bar hydraulic oil pressure is reduced to at around 80 bars. Then only after reduction it is So the sealing oil is supplied to this FVIV. Now there will be pressure fluctuations in the system. So for that, sealing oil accumulator is connected to this sealing oil system. So this sealing oil accumulator will basically reduce the pressure fluctuations. And for monitoring the pressure, there is a pressure transducer installed onto this system, and for the safety purpose there is a pressure switch. So this, as I have already told you, that this sealing oil is a part of safety. So till the pressure is not there in the system, the secondary fuel, the basically the main engine will not change over from primary fuel to secondary fuel. And the second thing is, if there is a reduction in the pressure during running condition of the main engine onto the dual fuel mode, then at that time it will trip the system. So the safety is incorporated with the help of pressure transducer as well as the pressure switch, which is installed onto this sealing oil system. So mostly I have tried to cover the major components which are incorporated onto the cylinder head for the operation of main engine on dual fuel mode, or you can say the secondary fuel. Now, if we cover the injection sequence of the LPG into the combustion chamber, then it will be very clear that at what stage of injection which components are coming into use. So let's see the injection sequence into the combustion chamber, so that the whole things which we are talking till now, that will become more clear. So before we go on the working principle of FVIV, or the injection sequence, let's first see what all components are there onto this FVIV valve. So as you can see over here, this is the plunger. The hydraulic oil at 200 to 300 bar from the LV is applied onto this plunger through this hydraulic pipe. Now, next thing is the suction wall. So this suction wall is basically incorporated onto this plunger itself. So the LPG enters from here, and through this suction wall it is getting collected onto this combustion chamber. Now when the hydraulic oil is applied onto this plunger, then the LPG in this combustion chamber, sorry, the booster chamber gets pressurized, and it gets pressurized to a pressure where this non-return valve will open. So basically this non-return valve is provided over here. So there is a thrust piece. So this thrust piece basically pushes this cutoff shaft, and it keeps the holes or injection holes shut at all the time till it is supplied with the hydraulic oil from the LG at 200 to 300 bars for the operation of this cutoff shaft. So basically there are very few components on the FVIV. The plunger is there for the pressurization of the LPG. Suction valve is there for filling the booster chamber. Then we have a non-return valve as a safety. Then there is a thrust piece. So this thrust piece basically keeps the cutoff shaft close. And when the hydraulic pressure is supplied, then at that time this hydraulic pressure from the LG pushes this cutoff shaft, and it opens the hole for injection of LPG into the combustion chamber. So if you see this diagram over here, the hydraulic oil from the LV is basically applied onto the upper part of this plunger for pushing the plunger down, and the control oil is supplied through this hole, and it passes through the internal holes of this FVIV, and this is applied onto the cutoff shaft for pushing it upward. So when the cutoff shaft is pushed upward, then the injection holes are opened, and at that time LPG is injected into the combustion chamber. So now we will see a little bit about the sealing oil. So as I have already told you, that the sealing oil at 80 bar pressure is always maintained in the FVIV for the safety purpose. So the sealing oil basically separates the high pressure hydraulic oils from the LPG. So as we know that the hydraulic oil at around 200 to 300 bar is supplied onto the upper part of this plunger, and LPG is there in this booster. So in between there will be a sealing oil in this section. It is maintained at 80 bar in this section on the upper part of the plunger. Now after the LPG is passed from this booster chamber, after this non-return valve, then it waits near this cutoff shaft. as you can see over here. The LPG is there, the LPG is waiting over here near this cutoff shaft, and this cutoff shaft needs to be operated by the LG valve for the injection of the LPG into the combustion chamber. And for that purpose, this oil, as you can see, this oil is supplied over here. So to separate this high pressure oil from the LPG which is supplied over here, sealing oil is also maintained over here. So sealing oil pressure of 80 bar is also maintained over here for its proper functioning. So now let's see the working of FVIV, or you can say the injection principle of this FVIV. So when the LV wall is not active, basically when there is no hydraulic oil pressure on the top of this plunger, so at that time the LPG which is supplied at 50 bar will basically enter through this hole, and it will pass through the whole internal holes in the plunger, and it will open this suction valve. So this suction valve will open, and this booster chamber will be filled by the 50 bar LPG. So as we know that there is no hydraulic oil pressure on the top of the plunger, so what this 50 bar pressure will do, this will push the plunger in the upward direction till the time there is no movement. So when the this plunger reaches the top part of the FVIV, then at that time the suction valve will close. As you can see over here, the suction valve will close. Now after the suction valve is closed, the LV activates, and the hydraulic oil of around 200 to 300 bar pressure acts onto this plunger, on top of this plunger, and so this plunger will basically move down, or the hydraulic oil basically pushes the plunger downward. So when this plunger moves down, the LPG will start getting pressurized, and it will get pressurized till the non-return valve opens. So till the time non-return valve is not open, then till that time the LPG will continue to get pressurized onto this booster chamber. Now the set pressure for this non-return valve is at around 80 bar pressure. So when the pressure when this plunger moves down, then the LPG over here will get pressurized to 80 bar pressure. Then after 80 bar pressure, this non-return valve will open, and these holes will get connected to this booster chamber, and the LPG will enter this holes, and it will wait near the injection holes, and it won't get injected because the holes are covered by the cutoff shaft. So the 80 bar at 80 bar the non-return valve will open, and the holes will get filled up with this LPG. Now the plunger is still moving down, so the LPG onto this chamber plus these holes will be getting pressurized continuously, and it will get pressurized to at around 600 bars. So the LPG, after opening the non-return valve at 80 bar, it will get pressurized to at around 600 bars with the help of this plunger. So now we have the pressurized LPG which is waiting over here near the cutoff shaft, or you can say near the injection holes, and these injection holes are basically covered by this cutoff shaft. So the only thing which is left for the injection of this pressurized LPG of around 600 bar into the combustion chamber is operation of this cutoff shaft. So now the LG, as you can see, this LG activates, and this LG basically pushes this cutoff shaft upward direction, in the upward direction, and when the hydraulic pressure of the LG valve basically pushes this cutoff shaft up, then at that time the LPG is injected into the combustion chamber. Now let's summarize the whole injection process in one go. So this LV, when it is not activated, then the LPG which is supplied at 50 bar pressure basically opens the suction valve which is incorporated in the plunger itself. So this 50 bar LPG is filled onto this booster chamber, and then this 50 bar pressure pushes the plunger in the upward direction, as there is no pressure on the top of this plunger. Now after the plunger reaches at the top position, or basically its movement is stopped, then the LV activates and it supplies the hydraulic pressure at around 200 to 300 bar pressure onto this plunger. So this plunger basically starts moving downward. So when it moves downward, it pressurizes the LPG into this combustion chamber. The LPG over here is maintain will get pressurized till 80 bar, because that is the set pressure for the non-return valve. As you can see over here, that is the set pressure for the non-return valve. So after 80 bar pressure, the plunger is still moving downward. So what will happen? The non-return valve will open and it will push the LPG through the non-return valve onto these holes near the cutoff shaft. So the LPG will now wait near the cutoff shaft, and still the plunger is moving downward. So what will happen? The LPG in the booster, this booster chamber, as well as on these holes, will continue to get pressurized, and it will pressurize to around 600 bars. And after the LPG reaches 600 bars, the LG will operate, and the LG will supply 200 to 300 bar hydraulic oil below this cutoff shaft. So this hydraulic oil will basically push this cutoff shaft in the upward direction, and it will open these injection holes, and LPG will get injected into the combustion chamber. So this is how the injection of LPG takes place into the combustion chamber of LGIP engine. So friends, I had tried my best to cover what all things are possible, and if you have any doubt, so you can ask me, and if I don't know anything, then I will ask my seniors and I will try to clear your doubts. And one more request, that friends, please try to share these videos with your friends, because coming shifts will have dual fuel engine for sure, and this is just the only one type of dual fuel engine. There will be many different types, but the main concept or the basic concept will always remain same, because these ships are designed as per the class, and the class requirements are almost same. So the design principle will be little bit different, but their operation principle will be almost same. Now we have covered the major part of this dual fuel system. Now the control system is left, and the auxiliaries which helps the operation of this main engine to work on the dual fuel mode, like the nitrogen generator, that needs to be covered. So the control system, as well as and the safety system also, the control system, safety system, and the nitrogen generator. So all these three things I will try to cover in the upcoming videos. So till then, take care, have fun.